2. 2.4. Nope, 1.4. This is 1.4. Composites of functions. That just means that we are putting functions together. Okay, now, the first section we did last year. So that should be really easy for us to review and go through. So, in the first section, I want to again remind you on domain. How do you find domain? What are the two things that you look for when you're doing domain? Is there an x where? When we're talking about the domain, in the denominator, thank you, and is there an x inside of what? Square root. If it has no to either of those, it's all real numbers or negative infinity to positive infinity. Okay. When we are doing composites and finding the domain, I want you, 1, find the domain of each function. Then 2, put the functions together. And we're going to put them together as indicated. So maybe we're adding them, maybe we're dividing them. And step 3, find additional domain of composite. All right, so for example, let's say I have, example number 1, I tell you that f of x equals 1 over x, 1 over x, and then I tell you g of x equals let's go with, how about x plus 4? That's really easy. And in 1 and 3, we are going to add them together or subtract them. So let's start with that. We're going to go f plus g and find the domain. So in order to find the domain, the first thing we do is find the domain of f of x. Well, where can x not exist in f of x? There's a 0, or there's an x in the denominator, so x cannot equal 0, right? Okay. What about over here? Are there any restrictions in g of x? So this whole thing is negative infinity to positive infinity. Now we're going to put the two together. So f plus g equals 1 over x plus x plus 4. Then we look to see if there's any additional restrictions. In this case, there is not, because there's still just the x in the denominator, and there's no square root. So our domain for this whole thing has to include everything we know. It cannot exist at 0. This says it can exist everywhere else. So our domain would be from negative infinity to 0, 0 to infinity. All right, what if we then in 5 and 7, we are doing either dividing or multiplying? So let's do g divided by f. So in this one, if I take my g, which is x plus 4, and divide by my f of x, which is 1 over x. How do I go about simplifying that? I have a fraction in the denominator, which means I have to do what? Multiply by its reciprocal. So I have x plus 4 times by x over 1. Which which means I'm going to have what? What's x plus 4 times x over 1? Good. X squared plus 4x. So this is my composite function. My domain, however, although that says that I don't have any restrictions, I have to take into consideration the restriction when we started. So my domain here would still be negative infinity to 0, 0 to infinity. Okay. 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 All right. So any questions so far? I want to do one more like this, but make it a little harder. You guys have, is there something we have a question on? Something we should... They're finishing that Stop the Bleed, but it was supposed to go to 2:30. Yeah, you guys don't do it for a while yet. No, seventh and up. All right. So let's go with example number 2. Okay, so it's going to be written like this. Maybe it says we have find f divided by g and g divided by f and their domains. And let's go with f of x equals x squared and g of x equals the square root of x plus 4. All right, so first of all, what's the domain of f of x? Very good. It is negative infinity to infinity. I agree, because there's no x in the denominator and there's no x inside a square root. For g of x, what's my domain? I take what's inside here, x plus 4, and set it greater than or equal to 0. Subtract 4 over, so x has to be greater than or equal to negative 4. Right? Or I can write it as negative 4 to infinity. Now we're going to go ahead and put them together. Let's do the first one. F divided by g. So if I do f divided by g, that means I have x squared over the square root of x plus 4. So now we've got to look and see if there's any additional restrictions before we write this. In the denominator, this, even though it's a square root, it cannot equal what? So can I still have a bracket here? I can't have a bracket anymore because if I were to put negative 4 in here, it would give me 0 in the denominator, right? So I cannot have a negative 4 inside that square root. Okay, so I'm going to put that here. X cannot equal negative 4. All right, so now, out of all of those domains, we've got to put it all together. So my domain, I'm going to put it on a number line. First of all, this says it can be anywhere. Okay. This one says at negative 4, it starts here and goes this way. And this one says it can't exist at this spot. So my final domain is going to be a parenthesis, negative 4 to infinity. All right, let's do g divided by f and see how that changes it. Back a little bit. G divided by f. So if I take my g, which is the square root of x plus 4, over x squared. Now what additional restriction do we have? Correct. X cannot equal 0 this time. So when I look at my domain, this one is fine, right? I'm looking at this one on my number line. Oops, let me put it in black, sorry. on my number line at -4, it's a closed dot, and it goes this way. But I can't have 0. So here at 0, I have to have an open dot. So how would I write my domain that would state that? Good. A U, and then I can jump over 0 and go to infinity. Exactly. This is going to be the hardest thing in today's lesson, is finding that domain. Okay, this is the hardest part. Any questions? All right. Next part of composite is fog, or f of g of x. So if you recall, one of the functions we did last year was f of g of x, or it can be written as f of g of x. Do you guys remember that notation? Good. Okay. This says whatever number's in here goes into the g function. Whatever number you get out goes into the f function. Okay, so for example, if I had f of x equals x minus 4 and g of x equals 7x plus 1, and I want to know f of g of 3. I'm going to take this 3, plug it into my g equation. So I have 7 times 3 plus 1. 7 times 3 is 21 plus 1 is 22. Then I take that 22 and I have to put it into my f equation. So then I have 22 minus 4 equals 18. Do you remember doing this last year? Okay, good. Good, good, good. So then, whether it's written in this notation or this notation, you have a couple of them where you have numbers to do it. Okay? So let's do an example of that. So here's example number 3. The way it will be written, it will say find f of g of 3 and g of f of -2. And then maybe they tell you that f of x equals x squared minus 1 and g of x equals 3x plus 1. So let's start with the first one. We're going to do f of g of 3. So we start with 3 and plug it into where? Plug it into g. So we start here. So I have 3 times 3 plus 1. Then we take that 10, I like to write my 10 there so I know where it goes, and I put it into my f. So I have 10 squared minus 1. So I get 99 for my first answer. Now let's do g of f of -2. So this time I take -2 and I plug it into f. So I have -2 squared minus 1 is 3. I agree, Emma. So I have 3 here. I'm going to plug that into g. So then I have 3 times 3 plus 1, which equals 10. Any questions on those? Okay. So now we're going to get a little more abstract. And I only say that because now we're going to take away the numbers. We know the process. We're going to take the number away. Okay? So here is example number 4. We are going to do in the last section f of g of x and g of f of x. And so let's say f of x equals x minus 4 and g of x equals x squared. So starting with this one, we're going to do f of g of x. So what this notation actually says is that I am taking g of x function and putting it into f. So I am taking this whole function of g and putting it where x is in the f equation. So this becomes x squared, so I'm taking that and putting it there, minus 4. Now let's do it the other way. If I'm doing g of f of x, I am taking this f of x equation and putting it in the g equation where x is. So this is going to be x minus 4 squared. So what do you think we have to do with that? We've got to multiply it out. And how do we multiply it out? Got to do the box. You're right. So x minus 4 times x minus 4. X times x is x squared. X times negative 4 is negative 4x. X times negative 4 is negative 4x. Negative 4 times negative 4 is 16. So this final answer is x squared minus 8x plus 16. I would like to do one more like this, and then I'll be done. Okay? And that'll be it, since we're only going to go to 21. All right, so example number 5. Again, we are going to find f of g of x and g of f of x. And this time, let's say that our f of x equals x squared minus 1, and our g of x equals the square root of x plus 1. All right, so let's start with f of g of x. Oops, I just wrote that wrong. F of g of x. So I'm going to take my g of x equation, which is the square root of x plus 1, and put it into my f of x equation where x is. So I have the square root of x plus 1 squared minus 1. Well, how do I square a square root? They cancel, exactly. So I'm going to have x plus 1 minus 1. So what does this one simplify to? X. Very good. Okay, what about this other one? Let's try going the other way. G of f of x. We're going to take our f of x and put it inside of where g is. So we have the square root of x squared minus 1 plus 1. All right, so to simplify this, underneath the square root, I have x squared minus 1 plus 1. What is going to cancel each other? Well, you can't cancel the square root yet. Negative 1 plus 1 will cancel, right? And then I have the square root of x squared, which equals x. Absolutely. All right, questions? You guys want to get started? Okay. Now, there is one graphing one where they're asking you to graph two things together and just show on your paper what it does, which I know you guys can totally handle. All righty.